All right. Hi, everyone. Today I'll be talking about how to use Excel and what sort of expectations I'm looking for in using Excel in the lab, and hopefully you will get some insightful information from this video, not only to just generally work with Excel, but how we'll be effectively using that in lab. So I have up right now the Excel sheet that hopefully you downloaded from Blackboard already. If you're using an older version, I have updated this particular cell value to negative 9.8. So if you just go to that cell, click on it, and if we double click on it, once it's highlighted, and right in front of the number, just put a negative sign in front of that. Once you're done, just press enter, and then that should be corrected for future use. So just note that, and we'll be moving on to the next thing. So what we'll actually start with is a discussion about statistical error. This kind of accompanies a discussion that we had in the very first lecture pertaining to statistical error and how we would express that both through our analysis, through the use of Excel, as well as how we would discuss it in terms of our conclusion statements at the end of our reports. So in order to go to this particular page, you'll have to go down to the bottom here where there are two tabs, one labeled Graphing Techniques, which is where you would probably be starting from, and then you'll just click on the one that says Statistical Error, and we'll begin from there. All right, so hopefully we have a table that is semi-filled out for us, where observations are viewed here from 1 to 20, and then we have just some random numbers thrown in here of some fictitious object that was measured in terms of its length, or say diameter, something of that particular nature, where we would probably be using a ruler to do that. All right, and so to help facilitate this discussion of using Excel, as well as dealing with the statistical analysis that we'll eventually be doing in lab, what I've chosen to do here is to show how the functions kind of work in Excel by explicitly calculating the individual steps within calculation of the standard deviation. Excel actually has a function that automatically does that for us, and we'll actually compare the work that we do in this particular manner to the actual Excel function value. That should hopefully come out to be the exact same. All right, so just to kind of give a little bit of overview to that, just to kind of show the steps involved with doing that calculation, I'm going to switch over to these handwritten notes that have the standard deviation of a sample written out in its summation form here. Honest time, I forgot. This should actually be to n, not to infinity. So to make that correction, I'll just do that right now. It should be to capital N, basically the total number of measurements that are made in the sample, not to infinity. That's an error on my part. And so what we'll do is we'll be explicitly calculating each of these steps in the process of calculating the standard deviation of the sample. Again, just to reiterate, since we're calculating the standard deviation of the sample, This means that the denominator inside the standard deviation is an n minus 1 rather than an n, where n would be n and just n in the denominator would be for the standard deviation of the population. So just to make a note of that as to why we're using this form of the standard deviation versus another is because this is defined for the sample set, right? We'll go through each of these processes, calculate the residual squared, take the sum over the residual, and then finally calculate the standard deviation. Finally, once we get the standard deviation, we'll then need to calculate the standard error of the mean, which is found by taking the standard deviation and dividing it by the square root of the sample size. As of right now, for my viewers that are taking the course with me, it is not important at this moment how this is necessarily derived. We'll get to that discussion later in a more advanced course called error theory. Okay. Once we calculate all those things, we'll eventually calculate what is called the percent difference or the percent discrepancy. I usually prefer to call it the percent difference, though that may have different definitions on who you ask. And normally I use the absolute values, mostly around the difference, just to make sure that that is positive, but I also just for completeness put it around the theoretical value, just in case if the theoretical value we're comparing to might happen to be a negative value. As an example here, many students will go about measuring the acceleration due to gravity, which usually has a negative sign associated with that, and usually we compare to this particular value at the surface of Earth. Okay, so that kind of completes essentially what we're doing in this portion of the Excel sheet. And then in the next one, I'll talk about how we kind of do the graphing techniques and what I would expect to see as a nice graph to then copy into your report for final submission. All right, so here in this column of observations of some measurement X, we have values roughly around the range of 1.5. However, in our measurement process, we sort of estimated the second digit of the measurement, the second decimal, sorry, of the measurement itself. And so we want our Excel file or our spreadsheet to sort of reflect that particular notion that even though that we have typed in 1.5 centimeters, it is technically 1.50 centimeters, since that 0 is significant to us in that particular instance. So what we will do is we will click and drag and highlight the 20 observations made in that column. And to formally do this, once you've highlighted the cells, you'll then need to right-click on the cells, and then a drop-down menu comes up, and we'll then go to Format Cells. Once we get to Format Cells, in the Number tab, which is usually the default tab that's open, we can select what kind of category of number that we're going to be working with. In our case, we'll be working with the number category, as opposed to some other ones which may come in handy later on, such as scientific and even percentage may be important later on. Here you can tell it how many decimal places you wish to show, and normally this would be dictated by essentially the measurement device we're using. And in our case, Since we're estimating to the second decimal place, we want to make sure that we show 2 decimal places in each of those cells. Once we do that, we say OK, and then the menu closes and we get this particular result, which is what we wanted in the first place. A shorthand way of doing this is also by clicking and selecting the 20 cells that we're trying to manipulate, and then going to the Home tab, and then in the middle here, we can do the same thing. We can have a drop-down menu where we change the number, the category to number, and it might do it to the appropriate number of decimals that we want automatically, or we may have to adjust the number of decimal places underneath that drop-down menu by either clicking to make them bigger or make them smaller, depending on what we are needing. Note that if we make this smaller, standard rounding will occur for the values in that particular column. Just note that if we use the data set, say to calculate an average, it will still use all the significant digits that are hidden by this particular feature in Excel. So do be aware that if you're trying to calculate, say an average from rounded numbers, you may need to explicitly write them in that rounded form beforehand. Otherwise, it will assume that you want every significant digit that isn't a 0 to be used in that full function. Right. Also, you don't necessarily have to go to the drop-down menu to change the category type. Simply by just changing the number of significant digits shown of the cell selected will automatically change it to the number type category. All right, so moving on with manipulating these significant digits, I have to admit, for the most part, I'm not terribly much of a stickler to significant digits, though I do ask students to be cognizant of how many significant digits they're displaying, particularly from calculated results that may involve very long decimals and things of that nature. My general rule is somewhere between 2 and 5 significant digits is basically what we would normally have in many of the labs that we would, in fact, go over. So just note that if you're going to be displaying particular numbers that are derived from a set of data entries, that you need to make sure that you're not claiming more precision than you already have. So try not to overclaim that too much, though most people may not necessarily question it if it is in a reasonable range of precision with relation to the data that was collected. All right, so to give that as an example of how we formulate functions in Excel, we'll first calculate the average of these 20 data points by first highlighting the cell that we've labeled as average. And we'll press enter, we'll press the equal sign, and we'll call the function average. All right, and it doesn't have to be in capital letters, it can be in lowercase letters. Excel will automatically change the case of the letters to capital once the function has been correctly entered and used in the cell. So once we select the average function, we type in a parenthesis to indicate that we want to enter in values to take an average over, or select a range of cells in which we want to take an average over, which is usually the case. Many times we're taking the average. All right, once we've selected our range, if we need to select another range of cells that we wish to take an average, or say standard deviation, we can press the comma key and then select another set of data to take an average over. But since we're all in one column, we'll just end there at C22 and press enter. Now here, fortunately for us, I believe this actually comes out to be a decimal number at the hundredths place without any sort of rounding from any of the numbers provided in the observations above us. So fortunately for us, we are able to get a number that is in the appropriate number of significant digits. All right, moving on, more than likely we'll be using derived functions in Excel, more so than just what Excel provides for us. So that means that we would have to generate our own functions as we need them and as we see fit. So again, like any function, we start with an equal sign. And to take the residual, what we're going to do is we're going to take each of the individual observations and subtract it from the average. All right. So for all intents and purposes, we can select the observation first and then subtract the average, or we can do the average minus the observation. The reason why this doesn't matter in the end is because we're going to be squaring the value of the residual. And that will remove any minus sign that is incurred by any order of how we calculate the residual. For this purpose, we'll just start with the observation first, and then subtract the average value from that. Right? So this is a very basic function of just subtracting two numbers from each other. And hopefully, clearly we see that 1.5 minus 1.54 gives us a minus 0.04 result. So at least it makes sense at that particular level. Now, normally, instead of going through and doing the same thing over and over again, which can be a fairly tedious task, particularly if you have a large data set like I'm doing here right now, what you can do is you can always just copy and paste. You can always do it in this particular manner by copying and pasting in the formula. Okay. Another way to do this would be by taking and selecting the cell in which you have the formula, and particularly if you're just going to run it down the column, what you can do is take your cursor, which is normally a white cross, and then go to the lower right-hand corner where it turns into a black cross. Click, hold, and drag until you are reaching whatever limit you have. And then it copy and pastes the formula, iterating the cells in a particular interval set as you click, copy, and drag the formula down the column itself. So if we go somewhere down here, you see that it selected that and a cell down here. This is not what we want. What we really wanted was the average to be referenced continually in our residual calculation. Now, there are multiple ways to do this. One such way of doing this is by hard coding the value into the equation itself, such as putting 1.5 in and then getting the correct value of the residual in that manner. However, if the average changes, you will then have to go back and change the value that you've hard-coded into the function itself, which is something that may occur depending on the situation and the type of lab you're working with. So instead of doing that, what we're going to do what's called a static reference. All right, so clearing all of that, if we go back and double click into our original residual, we then go into the function, and you can go up to this field here where you can manipulate the function as opposed to manipulating it directly inside the cell. And they color coordinate according to which cells they're referencing in that particular type of view. Now, to do a static reference, what we'll need to do is basically form what I would call sort of a crosshair of location. So you want to set the row number and the column letter and fix those into place. And so fortunately, Microsoft has done that for us. And so to lock those two coordinates into place, the column, what we'll do is put a $ in front of the column letter, sorry, and then a $ in front of the row number. Now note that I'm not putting a $ in front of the other number, just in front of the very first row number. All right, and if you go further and further over to your right on the letters for the columns, you will also get multiple letters at some point of repeating variance, and then in that case you would have to again just put a $ in front of the first column letter, not in front of all column letters, to get that static reference to occur. Once you get it, hopefully by pressing enter, nothing has changed, which indicates that what we have done is successful. Otherwise, it may pop up with an error message, say if in the event that maybe I did this, and then it comes up with an error message saying something is wrong with the formula. Okay, in that case, I was referencing a cell with letters in it, which Excel doesn't like to use in terms of functions. So this is why one very important thing to note is anytime that you need to put units associated with each of your observations or results that you calculate, it's important to either offset them to, say, a column title, or offset them into their respective rows, depending on if the column, the values in the column are changing based on what's being calculated in each of those cells. So those are just some things to note. If you are getting errors associated with the inability to calculate certain things, more than likely you have inside referenced cells something that can't be used in terms of an evaluation of numbers, so like a letter or a non-numerical symbol. That doesn't associate itself necessarily with proper notation in functions. All right, so since we have our function set up the way that we want it, we can then just copy and paste. And lo and behold, if we double click, if we double click into one of the cells that calculates the residual, we see that it statically references the average just as we want and varies along the column with each observation as we go down the calculation of each residual. All right. just to sort of reiterate that fact of the fact that we were statically referencing as opposed to hard coding the number, I'm just going to show as an example that if I put 2.63 in here, it will automatically change the residual as a result of the change in number that it's statically referencing. So if you kind of did that for yourself, just change it back by going back and undoing that and making sure that it's the average of the cells of 1.54. Next, we'll calculate the residual squared. So we'll start our function again as usual. And then we'll then reference the cell that we're going to take the power of. You can do this multiple ways. One such way is doing the multiplication of itself twice, or 3 times if you're doing a cube, 4 times if you're doing to the 4th power, so on and so forth. In our case, what we're going to do is we're going to do power squared. And so one way, like I showed, was multiply it by itself, or we can call the caret symbol to indicate that we're raising to some power. Though it is not necessary, sometimes just to be absolutely certain, we can put parentheses around the power in which we're taking that reference cell to. So once we get that, we press enter and we get this particular value here. Another such example to do this is through the power function. If we type in power, parenthesis, reference cell, comma, 2 to square, we get the same thing. If I were to copy and paste that up, nothing changed. The only thing that changed was the function style. However, the function still calculated the square of the residual. Now, one thing to note, I believe in this particular form of the power, you can do fractional powers, such as 2/3. So calculated it there. This also works with the caret method. And then it gets us the same value as before. Do note that if your value is negative, fractional powers may have a problem being calculated in such a manner as the root that you're going to be calculating may not be real. So just be aware of that. It will not calculate complex numbers for you and will throw an error for you if that were to happen. All right, so going back, we'll just use the power function in this particular case, and we'll copy and paste it down like we did for a function. Since we're only referencing the cell next to us, we don't have to do any sort of static reference in that particular case. All we care about is just a single cell that's right next to the one we're manipulating. Next, once we get to that, just like we did with the average function, we'll calculate the sum by typing equals sum, and then taking the range of the residual squared that we're going to take the sum over, we'll then calculate it in this particular manner. Here I might have already, I guess not. Oh, it's okay. So sometimes I have to kind of check to make sure I didn't preset something in my Excel sheet that may give the false sense that I have a good enough significant digits being shown. So let's just checking just to make sure I did that okay. All right. Finally, to calculate the standard deviation, what we need to do is we need to take the square root of the sum all over the number of observations minus 1. And this will show us a few things. One such thing is that there is, in fact, a square root function by itself. We don't have to take a 1/2 power. Again, reminding you that you could, in fact, do a fractional power. But in our case, since we're just doing the square root, we'll just use the square root function. And so we had the sum of the residuals squared in our numerator divided by the number of observations minus 1. Now, one thing to note, before we press enter and calculate this value, we need to note the fact that order of operations will occur in Excel. So be very, very aware of that. If you want the difference to be calculated before the division, make sure that you have the appropriate parentheses around that so that that is done prior to the division inside the square root. One other thing to note is that multiplication must be done explicitly in Excel. It does not accept implicit multiplication. I can show an example of that once I calculate this. Okay, and so we see that we get some sort of calculation of the standard deviation. Okay. So, right, and we'll compare that to what the Excel function itself gives us. So say in our equation we wanted to do twice the residual squared. What you would do is you would do 2 times the residual squared and press enter to get that value. This is what would be called explicit multiplication. Implicit multiplication would look something like this, where we take 2 times E3. If we press enter, we get this value or this error message, and it tells us that we need to do this explicit multiplication here and may ask you if you want this correction to be made. In our case, we would say yes, and it changes it automatically. Sometimes it may not necessarily know what you're wanting to do and may have to tell you to check your formula again. So just be aware of that when you're generating your own formulas in Excel. For right now, what I'm going to do is I'm just going to leave the standard deviation in the number of significant digits that are shown right now, just for now. And we'll call that function standard deviation, so STDEV. And then the type of standard deviation that we're going to choose will come in either 2 forms. One will be of the population, or .p, or of the sample, which is .s. And since we said that we were working with the sample, standard deviation of the sample, we'll choose the .s version. Now, we're going to take the standard deviation over the original set of data points. Do not include the average, which may be calculated in addition to the standard deviation, into this range of numbers, as it may treat, as it actually will treat the average as another observation itself. This function automatically calculates the average in order to calculate its own residuals and things of that nature in the background. So please don't include the average in your total observations that you're referencing. Okay, so again, just like the average before, we'll reference the 1 through 20 observations, close off the standard deviation, and lo and behold, we get basically the same number that we calculated from above. So that kind of shows the use and power of manipulating cells in Excel to do what we want to do in the end. Now, do note that just because we calculated the standard deviation in Excel, and that Excel has its own standard deviation calculator that does it pretty much in one cell calculation. That doesn't mean that everything that is possible could be calculated in such a way. You could, in fact, make your own functions. I believe that is capability within Excel to do. However, I'm not going to teach that here. That would be for something more advanced and probably a little bit more specific to your needs that go well beyond standard statistical calculations that are done. All right, so oftentimes what will happen is Excel will just pop out a random number of significant digits for whatever reason, normally based on the width of the cell itself. However, we again would want to manipulate these such that we get a proper number of significant digits being shown. So if we want to go by the proper significant digits, we would have 3 and 3. However, since we know that we're going to be using this in errors, typically what we do is we do this to the appropriate number of decimal places shown in our final result. So our final result has 2 decimal places, so we can make it 2 decimals in length for that. In either case, even showing up to 4 is okay. It's not the best practice, but it's certainly not 9 digits from basically a non-rational number that is just continuing on indefinitely in the background. So just be aware of that. Try not to show too many significant digits in the end. Next, again, we're going to calculate the standard error. So to start that function, we'll start it with an equal sign and reference the standard deviation. Since we more or less showed that both standard deviations are the same, you can select whichever standard deviation you like. I'll go with the one that we calculated, just to know that I feel confident in the standard deviation calculation I made. And we're going to divide it by the square root of the sample size. So again, we call square root. And just like we did before, if we know the number of observations we made, we can simply type it in and hard code it into here and calculate that in that particular manner. Another such thing that you can also do is you can always call the count function. The count function, just like our average and standard deviation, will run over the number of observations made. When we put it in parentheses, just like such. And then we'll need to add another parenthesis to close off the square root. Once we press enter, we see no changes in that particular instance. But say if we perhaps delete, actually, sorry, say if observation 20 is no good and we want to delete, well, let's just say that it is available for remodification if that is necessary to be done later on, I believe. Let me try one more time. Okay. So if you were to delete certain things from the calculation here, oops, it's wrong now. Okay, there we go. So this is referencing 20, whereas if we did the count again in the standard deviation calculation, like we did before, we get the same standard deviation here. So if you need to manipulate the data in any way, shape, or form, sometimes providing the function itself rather than hard-coded numbers in here is usually better for long-term use and manipulation of future data that may come into play later on. All right, so I'm going to undo a lot of this. Make sure everything looks okay. Oops. Oops, I'm going to undo that. Oops. You'll notice that if you're inside a cell, you try to click out of the cell, it might try and do something funny. So just make sure if you're inside a cell like this, just press enter to escape and get out of that immediately without messing up your formulas and things like that, and having to try and figure out where things went wrong. So just one thing to note. All right, lastly, with the statistical error, we are going to then do the percent difference or percent discrepancy. And so what this was the absolute difference of the theoretical value, which I just so happen to say is 1.55, against the average value of 1.45 divided by the theoretical value 1.55. So again, we'll take the absolute difference, and to call that, we'll do ABS. And the number that we're going to put in here will be a difference number between the average and the theoretical value. In this case, if we press enter, we get 0.1, which is the absolute difference between this and this. So it did, in fact, cover the fact that it would have had a minus sign had we not had the absolute function being called. In our case, since we know that the theoretical value is not negative, we don't necessarily have to encompass it inside the absolute value, but in order to be complete, what we'll do is make sure that it is also included inside. And what we'll do is make sure that the difference is being calculated first, because we have to follow order of operations. And once that is done, we then divide by the theoretical value and select that number. Once we get that, we then get a decimal percent difference. Right? So we'll need to convert this into a percentage, either by multiplying this value by 100, which is a fairly crude method of doing that, or what we can also do is go to the Home tab and have the drop-down menu bring us our taskbar. And then again, here in the number section, we're going to change the category. Instead of a number, we're going to use a percentage. And this would automatically convert it into a percentage by multiplying it by 100 and adding in that percent sign. Very last thing, again, Excel is just giving us as many significant digits as it possibly can. Again, we don't want that, so we want to shore those up. And again, we can show 3 decimal places. Technically, we can show up to 3 significant digits, so we can show up to this. For standard practice of significant digits, or usually what we would do for error is, again, we'd show it to the number of decimal places that our value ends at, since that is where we have our uncertainty. So what we would do is we would report the value of 1.54 plus or minus 0.03 centimeters as the x value of some object. So say the diameter of a metal cylinder, if that was what was being measured. Okay, so that's how that would be expressed in your conclusions. And we had a percent difference of less than 1 at 0.65%. All right. So that concludes statistical error. The next video, I'll go over graphing techniques really quick and kind of show not only working with these Excel cells themselves, but sort of how to make nice looking tables that can eventually be inserted into reports just by simply selecting tables themselves and then copying and pasting directly into Word. So you don't have to necessarily manipulate Word document tables in Microsoft Word. All right, so that ends that. The next video, again, like I said, will cover graphing techniques and what we expect to see out of that. See you then.